Hello everyone, my name is Xiang Ruchen, a first-year graduate student in ECE of University of Florida. Today I'm going to introduce my final project of the course Image Processing and Computer Vision, the image sketch generation algorithm. There are 4 parts of this PowerPoint: the problem and study, the existing approaches, the performance evaluation, and final conclusion. To begin with, I prefer to mention the purpose of this research. At first, I noticed an interesting phenomenon that many people use the sketch as their head sculpture in the social network. A picture like this. This is not a real photo or a picture drawn by a painter. It's just a transformed picture using Photoshop or other softwares. So I try to find out how they make it and find many related research. They will be shown at below, and the sketch generation is part of the non-photorealistic rendering. That the use of the NPR become widespread, and the traditional algorithm has many flaws. It will cause the loss of picture, and there's still many problems with the with outline and background. The main topic of my study is explaining how to achieve sketch for the 4 algorithms: the improved traditional one, the space domain algorithm, and DFT and DWT based algorithm. Finally, I will analyze and compare 2 kinds of algorithm: space domain and frequency domain. The first algorithm is the improved traditional algorithm. Instead of only use the diagonal direction to get the gradient, the improved one use 3 directions: horizontal, vertical, and diagonal direction to get the outline. Then use a ghost filter to smooth the background. And there's some problems. The first picture is my photo, and the sketch has it seems like there is a relation behind me, but actually the original photo doesn't have. Just that's a problem. Maybe it's caused by a 3-dimensional picture, and it cannot handle it very well. But when it comes to the 2-dimensional, like the right picture, it can generate the sketch almost perfect, but there is something loose of the little circle of their outline. That's the flaw. And the second one is a sketch algorithm based on space domain gradient. It first computes the gradient between the proportion of red, green, blue between original pixel and the close pixel. Then do reverse processing to make the picture seem like the current one. And the effect is pretty good because it shows all the outline of the object in the picture, although it is a kind of light, but it has great integrity. And the second one is algorithm based on discrete Fourier transform. The positive transform shown as below, and use the 2-dimensional matrix to show the picture, and do the transform function like this. Then use a Gauss high pass filter to filter the low frequency part of image, so we can get the outstanding part, the outline of the object. Then use a Fourier negative transform to make it back to picture. The DFT based algorithm has a great emphasis on the main part of the picture, but when it comes to the background, there's many little circles. They were removed, and so it has a lower integrity. The final algorithm is the discrete wavelet transform based algorithm. It has a similar thought to the DFT based, but I want to emphasize the two wavelet transform function, the positive one and negative one. This picture is lighter than the DFT based transform, but this algorithm removes the important part more essentially. Almost they are only the main part of the picture, so it may be used in some picture recognize, and if they want to remove the unimportant part, the DWT based algorithm is a good choice. Here comes the existing researches. Since 20th century, researches about NPR has become popular, and I choose three research to discuss here. The first one is space domain gradient algorithm proposed by Wei Chang He. This algorithm is discussed above. That is the first algorithm, the improved traditional algorithm. That algorithm belongs to the space domain, and the second is DFT based algorithm used by Xun Li. This algorithm is used discrete Fourier transform as discussed above also. And finally, the final research is the automatic drawing algorithm introduced by Hai-Hui Wang. She introduced an interesting algorithm that the algorithm can make the computer draw the sketch just like human. Really interesting. Okay, next part is the performance evaluation. My report evaluates 4 parts of the image: the integrity of the processed image, the picture's outline, and the background filling, and the difficulty to achieve the algorithm. First, we talk about space domain based algorithm. It can make real-time transmission because it processes the original picture, the original pixel. It just handles the original pixel, so it can save time. It can generate picture with accurate outline, but it will cause a kind of image loss. And the frequency domain based algorithm need a appropriate threshold to get best performance, so it's a little harder to achieve it but it has a similar outline performance and more smooth background, and it needs more time to process an image, not real time, but it can solve the contrast between time domain and frequency domain. Finally is the conclusion. Both kinds of algorithm can get proper sketch, but there are still some varieties. We need to choose the algorithm depends on the demand. Like maybe some application need to process the image in a short time, so it need to choose space domain based because it has low latency. But if application want to maintain the integrity of the original picture, it need to choose efficiency domain picture. Yeah, that has a better performance. Okay, that's all. Thanks for watching. Bye bye. This part is about the demonstration of my computer program. And the first program is improved traditional algorithm. And it can, it has many loops of the little circle. And the second one is space domain gradient based. Okay, this is my picture, my photo, and it's compute the gradient. Let's wait a minute. If we choose a bigger picture, it will take a longer time. This algorithm has a good integrity, but it didn't realize the edge of the wall. That's its problem. The third one is DFT based. Okay, this time I don't want to use my own photo. The outline is really distinct, but there's no circles, and the stars is still there, but the lighter star is not. It's gone. The final one is discrete wavelet based. Okay, wait a minute. It should have two pictures. Oh no. It removed almost all the little circle. Only left the main part. That's its function. Okay, that's the demonstration of my computer program. Thank you. Goodbye.